In this lesson, let's talk about the Apple Mac, its charging part. The fault caused by the charging part is that our battery cannot be charged. Because the battery cannot be charged is mainly to control the battery charging. Everyone knows that our laptop, its charging is divided into two parts. The first is that the battery does not charge. Either it is a battery or the charging circuit of the motherboard. So what are the components of the charging circuit? The charging circuit is composed of the circuit board, mainly including this. First, the battery port. The battery interface may also cause no charging. The positive terminal of the battery port, we have to use a power detection pin. Second, the charging and discharging MOSFET. Third, charging large inductors. Fourth, charging IC. The charging circuit composition of all Apple notebooks are here. So how to analyze the charging circuit? The charging circuit is a charging IC to control the charging MOSFET. Put the voltage of the large inductor into the battery. Cause the whole not charging is cause of it, either the charging section or the battery port. The quality of the battery is measured by the replacement method. The battery port depends on the wiring, it may be corroded, or a component on the interface is damaged. The charging transistor is generally a MOSFET, and the probability of it being broken is quite high. This large inductor is for the isolation circuit. The barrier circuit is our first circuit to talk about. The large inductor of the isolation circuit. It is to charge the voltage of the large inductance through the discharge tube and the charging tube to the positive electrode of the battery. However, in this there is also mentioned EC. What is the role of EC? EC is here to detect power and data information, which is also very important. EC is not detecting if the electricity. It will not be able to control the charging operation of IC. It is mainly used to detect power and battery information. We analyze the charging circuits actually organized into this, analyze the charging IC and EC. So let's analyze the battery port first. It is a key to the upper pin position. In other words, the battery is no problem, but you see if there are any problem with the pins of the battery port. Next, let's take a look at what the battery port looks like in the circuit diagram. Let's take a look at this board from Apple. This part of it talks about the battery interface. Our battery is buckled on this interface. We believe that anyone who has repaired a notebook knows of these pins of the battery interface. 1 and 2 pins are positive. A side transistor connected to the charging transistor. Then charging transistor is the side connected to the large inductor. Typically, large inductors contact charging. Everyone knows that the common part of the saturated circuit is about 8.6 volt. Then the chip of the MOSFET is connected to the charging IC. We will talk about it later when we analyze the charging IC circuit. It's 3 poles controlled by us. When the next 2 and 3 pins are connected, they are our positive poles. 4 and 5, these 2 pins are detection of battery information. These 2 pins are connected to the charging IC. At the same time, it will connect to our EC. In other words, if you plug in the battery, if the battery cannot be detected, it may be possible to measure the diode value of the 4 and 5 pin. Connect to the battery port on the U9650 and connect to the one on the EC. Along the battery port, this is a transistor. In addition, let's take a look at the 6th pin. It's called the plug-in signal detect, battery plug-in signal. Battery insertion signal passes 10 kilo A6950. In other words, the battery port is not charged. It may be a component of the battery port. Like this, A6950 and C6950 can be removed, no need to install back. If there is no problem with the battery port light, we are going to analyze the charging tube and charging IC. Then the charging IC also needs working condition and incoming conditions. What are the specific conditions? Let's take a look at the working conditions of our charging IC. Then since we turn on without charging, there is no problem with the inductor circuit of the common point. The problem lies in the charging transistor and our charging IC. We have to understand this structure clearly. So that means if there is no charge. The first one is from the battery interface line and the charging transistor line. So let's take a look at the line of the charging transistor in the AC section. How does the slip line charging IC work? This is a battery interface. Next, let's take a look at how the charging IC works. Let's take a look at the circuit of the charging IC. Let's take a look at our drawing. We have to set this in the isolation circuit. U7000 is our charging IC. This is our charging IC, U7000. This is a charging upper and lower tube, Q7030. L7030 is a large charging inductor. It is 8.6 volt. I have talked about it before. It is a common point circuit of the isolation circuit. The electricity that passes through the common point passes through C7045, C7045, C7043, C7041, C7040. Send this power to here. This is a precision resistor R7050. This resistor must not be short-circuited. It is precision resistor 0.01 ohm. When it is replaced, it must be replaced by original value. Q7050 is a real charging transistor. It comes in from the S pole and goes out from the D pole. This side is just connected to the battery port. Among the Q7055 maintenance relatively easily broken, it will cause no charging. If there is no problem with the battery, we will find the components of Q7055 next. It is directly connected to the possible terminal of the battery port. Take a look, it's 3 poles controlled by our charging IC. In other words, if there is no level at the G pole, it may be that the charging IC is broken, which is a power detection pin in our charging IC. At the SMBUS, charge SDA pin of the charging IC. That is to say 10 pin and 11 pin are connected detection power pins and connected to the battery port. If the resistor to the ground is short-circuited, it may be that the charging IC is broken or the AC is broken. One is clock pin and one is data pin. After receiving the signal, it also has a battery detection signal ACIN. The original ACIN pins has to be tested. Our charging IC itself also needs to be supplied power. The power supply itself is the power received by the adapter. The DCIN pin is its first power supply. The ACIN is its second and insert signal. When the GPO does not have a high level, and Q7050 does not have a high level, we must first check whether the second line of the charging IC has power supply. Especially the R7001 in the picture is easier to break. Then check the VDD pin ACIN. The third step is to check the VDD pin. The VDD pin and the VDDP pin are also relatively easy to break. The output voltage of the internal regulator, 5 volt. Therefore, if the battery cannot be charged during maintenance, we will focus on checking this pin, including such styles. If the GPO of the MOSFET has no electricity, measurement MOSFET is no problem. Then measuring the GPO if there is electricity. If there is no electricity in several poles, then directly change the charging IC. After changing the charging IC, if it's still not good, find the working conditions of the pin inside the charging IC. You can find out how to repair our charging. Charging IC have more lights. In fact, the charging transistor and the precision resistor are the ones that are easy to damage in the actual maintenance. There are also original key pins of our charging IC, like element R7001, in which we should focus on during maintenance. Let's take a look at these two resistors, R7051 and R7052. These two resistors can be dropped. It is a resistance to detect the charging current. One is connected to pin 1 and the other is connected to the pin 2. These resistors are very important in maintenance. This is a charging IC, its general working principle and step. We need to check during maintenance. Really positive for the maintenance of what is it. Let's teach you how to repair no charge to the battery. Next, we will summarize the charging part we just taught. If the customer takes a laptop, how should we repair it if it can be charged? Here to talk about it, how to fix a no charge problem. Generally, our first step is to check the battery. Generally, the lifespan of our brand new battery in our laptop is 2 to 3 years. If it's using time long or having water damage, it may be damaged. Generally being water damage, or the using time is more than 2 years. Like this case, it is caused by the battery problem. If the battery is not broken, how to measure it? We generally use a substitution method to do this. Second, if there is no problem with the battery, then at this time we have to open a circuit diagram to check the battery interface. Look at the positive pole, SDA pin, SCL pin, and DEF pin. We have to measure the resistance of these two pins to see if it's an open or short circuit. Especially the SDA and SCL pin are also connected to the EC. It may be caused by the EC and cannot be charged. This is the connection between EC and charging IC. It may also be a charging IC, especially when it is short-circuited. When the circuit is open, it's usually disconnected. Generally, the positive pole will be connected to the fuse or inductor. These fuse and inductor are more likely to be broken. The chance of charging transistor broken is also higher. If these are alright, then what should we do? The third step is to replace the charging IC. It may be caused by the damage of the charging IC itself. What if changing the charging IC is not good? The fourth step, open the circuit diagram to check the working condition of the charging IC. Which components we should pay attention to? The key point is here. What pins of the charging IC is needed to be measured? One is DCIN power supply pin, and the second is ACIN plug-in signal pin. And now VDD and VDDP. Especially the resistance of the VDD pin is more likely to be broken. It also has a diode on the power supply pin. Remember, this diode comes from the power interface. We have to check these key pins. The output AC okay? It is 3.3 volt. It is connected to the EC. If you change the charge IC but still not okay, at this time you need to find the files of these key pins, including detecting the charging current of CSP and CSN. These pins are very easily to be damaged during maintenance. But most of the premise is that the probability of damage to the charging IC itself is relatively high. If the customer's machine is brought over for repair, this is how the charging part is repaired. The step must be clear. Our thinking is clear, the handle is also excellent, and the circuit diagram will also be read. So it is more convenient for us to repair it. Encounter this kind of failure, just follow my ideas and step to fix it. This lesson over. Goodbye, see you the next time.